Type P blood, the rare blood group. Most people have never heard of AZLAN ADNAN, MA. Sunday, 9th of August, 2026. Most people know their blood type as A, B, AB, or O, followed by a plus or minus sign indicating whether they are Rh positive or Rh negative. But the ABO and Rh systems are only two of many blood group systems found on human red blood cells. One of the lesser-known systems is the P blood group, more accurately described today as the P1PK blood group system, together with the closely related GLOB system. So does type P blood really exist? Yes, but there is an important qualification. P is not a blood type in the same everyday sense as A positive or O negative. Rather, it refers to a family of inherited characteristics involving particular molecules called antigens, found on the surface of red blood cells. The system was first identified in 1927 by the famous blood group researchers Karl Landsteiner and Philip Levine. Since then, scientists have discovered that what was once regarded as a single P system is considerably more complicated. What is an antigen? To understand P blood, it helps to understand what a blood group antigen is. An antigen is simply a molecular feature on the surface of a cell. Your immune system can recognize these features as belonging to your own body. If it encounters a red blood cell carrying an unfamiliar antigen, however, it may regard that cell as foreign and produce antibodies against it. The familiar A and B blood groups work this way. A person's red blood cells may carry A antigen, B antigen, both, or neither. The P-related systems work on the same basic principle, although the molecules involved are different. The P1PK system is based largely on small carbohydrate-containing molecules called glycosphingolipids. These are built through a series of biochemical reactions controlled by genes and enzymes. Two genes are particularly important. A4-GALT is responsible for making an enzyme involved in producing the P1 and PA antigens, while B3GALNT1 is responsible for producing the enzyme needed to make the related P antigen. There is therefore a miniature biochemical manufacturing system operating inside our cells, adding particular sugar molecules to larger molecules on the red cell membrane. P1 and P2, the two common versions. For most people, the P system is not mysterious at all. They fall into one of two common phenotypes, P1 or P2. A person with the P1 phenotype has the P1 antigen, together with PK and related P antigens. A person with the P2 phenotype does not have the P1 antigen, although PK and the related P antigen are present. The distinction between P1 and P2 is largely controlled by how actively the A4-GALT gene is expressed. In simple terms, genetic variation can cause the relevant gene to be switched on more or less strongly. P1 and P2 are therefore not diseases. They are ordinary inherited blood characteristics. They are also quite common, although their frequencies vary substantially between populations. The P1 phenotype is particularly common in some populations of European ancestry, but considerably less common in many East Asian populations. Then what is the rare P blood type? This is where the story becomes genuinely unusual. There is a very rare phenotype written with a small p, P. People with the P phenotype lack the principal P1PK and GLOB antigens that most people possess. Their red blood cells therefore look very different to the immune system of someone who has these antigens. Because their own cells do not carry these structures, their immune system can produce a powerful antibody known as anti-PP1PK. This matters enormously if such a person needs a blood transfusion. A person with the rare P phenotype cannot simply receive ordinary P1 or P2 blood. The donor's red cells may carry the very antigens against which the recipient has antibodies. That can produce a serious, potentially life-threatening hemolytic transfusion reaction in which transfused red blood cells are destroyed by the recipient's immune system. The P phenotype is extraordinarily uncommon, with estimates generally placing it at only a few people per million or less, depending on the population studied. That is why finding compatible blood for somebody with this phenotype can be extraordinarily difficult. There are other rare P-related phenotypes. The P phenotype is not the only unusual possibility. There are also rare P1K and P2K phenotypes. These involve the absence of the P antigen while retaining some of the other P-related antigens. Modern blood group science distinguishes these phenotypes according to precisely which antigens are present and which are absent. This is one reason the phrase type P can be misleading. The terminology has changed as scientists have learned more about the molecular biology of the system. The P antigen itself is now classified within a separate blood group system called GLOB, while P1 and PK belong to the P1-PK system. Nevertheless, scientists and blood bank specialists continue to discuss these antigens together because they are closely connected biologically and clinically. Why does any of this matter? For the overwhelming majority of people, it does not affect everyday health. Someone who is simply P1 or P2 does not have a medical disorder. In fact, most people will go through life without ever being told their P1-PK status. The importance becomes apparent when unusual antibodies are discovered during blood testing. For example, people with the P2 phenotype can sometimes naturally produce anti-P1 antibodies. These are generally weak antibodies and usually are not considered clinically significant for blood transfusion. The situation is very different with antibodies such as anti-PP1-PK found in people with the rare P phenotype. These antibodies can cause serious destruction of incompatible red blood cells. This is why specialized blood bank testing exists beyond the familiar A, B, O, and Rh tests. What about pregnancy? The P system has another remarkable medical significance. In women with some of the very rare P-related phenotypes, particularly the P phenotype, antibodies such as anti-PP1-PK can cause serious problems during pregnancy. The placenta contains P-related antigens. Certain antibodies produced by the mother can cross the placenta and react with fetal tissues and red blood cells. This has been associated with recurrent pregnancy loss and, later in pregnancy, with hemolytic disease of the fetus and newborn. This occurs when maternal antibodies attack the baby's red blood cells. This is not something that happens to people simply because they are P1 or P2. It is primarily a concern involving the extremely uncommon phenotypes in which important P-related antigens are absent and clinically significant antibodies are produced. The P system has another fascinating connection. The molecules involved in the P-related blood groups are not merely labels used by blood banks. Some of them also act as attachment points, or receptors for substances outside the blood group system. For example, the PK antigen can serve as a receptor for Shiga toxin, a toxin produced by certain strains of bacteria. P-related structures are also involved in interactions between certain bacteria and human cells. The P antigen has also been identified as a receptor for parvovirus B19, the virus responsible for fifth disease. This illustrates an important principle in biology. A molecule can have several jobs simultaneously. Evolution did not create these molecules specifically to make blood typing possible. They are part of normal cell biology. Blood group researchers discovered that small differences in these molecules also provide useful markers for distinguishing one person's red blood cells from another's. Can a normal blood test tell you that you have P blood? Usually no. When someone says, my blood type is A positive, that normally refers to the ABO and Rh systems. Routine blood typing does not normally report a person's P1-PK or GLOB phenotype. The P system usually becomes relevant when a blood bank encounters an unexpected antibody during specialized compatibility testing, or when there is a known history suggesting an unusual blood group phenotype. Laboratories can then perform additional serological or genetic testing to determine exactly which antigens are present. This is particularly important for people with extremely rare phenotypes because ordinary blood matching may not be sufficient to identify compatible blood. So what should you remember? The simplest way to understand type P blood is this. P blood is real, but it is not an alternative to AB, or O. It is part of a much larger network of human blood group systems. What was historically called the P blood group has, as scientific knowledge advanced, been divided into the P1-PK and GLOB systems. Most people fall into one of two ordinary phenotypes, P1 or P2, and neither is a disease. The extraordinarily rare P phenotype is different. People with it lack several important P-related antigens and can produce powerful antibodies against them. That can make blood transfusion difficult and, in pregnancy, can have serious consequences. The P blood group is therefore a good reminder that human blood is far more complicated than the familiar A positive, O negative labels suggest. Scientists have identified dozens of recognized blood group systems and hundreds of individual antigens. ABO and RH are simply the most familiar ones. Underneath those simple labels lies an extraordinarily intricate molecular identity card carried by every red blood cell.
The author has placed this work in the public domain. It may be freely imported, exported, shared, distributed, edited, modified, or reformatted without explicit consent from the author. As a visually impaired person, the author asserts his rights under the Marrakesh Treaty to facilitate access to published works for persons who are blind, visually impaired, or otherwise print disabled. 2013, wipo.int.
Share your thoughts in the comments below. Don't forget to like this video and subscribe to our channel to show your support.